Okay, today we're studying quantitative chemistry, stoichiometry. I added a blank copy of this to the OneDrive, so if you didn't get a copy in class, you can download and print it if you've got a printer. Otherwise, you'll have to do working in one of your exercise books. Right, so this is criterion 8, stoichiometry. So firstly, we're doing a bit of a recap. Most of this is actually phys sci recap. So you should be able to do most of it without me, really. But starting on significant figures, determining what's significant. So you start at the left of the number, you find the first non-zero number, and then you count how many numbers there are to the right. You do that for any number that has a decimal place in it. If it doesn't have a decimal point, it's a whole number. You count the first number that's non-zero, you keep going, you don't count zeros on the end. Alright, so how many significant figures in each of the following? So first non-zero number is the 8. After that, there's just one number. So 2 sig figs. Next one, first non-zero is the 2. So 1, 2, 3, 4. Because 0 counts if there's a decimal point. First non-zero is the 7. 1, 2. 0 doesn't count because there's no decimal place. For this one, 1, 2, 3. We count the 0 because there is a decimal place. Sig figs here, just 2, don't count the zeros because there's no decimal place. Here we do have a decimal place, so we count zeros on the end, so 1, 2, 3, 4, 5, 6 sig figs. I'm going fairly fast because this is just a recap. Knowing how many significant figures to put in your answer. So the number of significant figures you put in your answer when you're doing multiplication and division should be the same as the value in the question that has the smallest number of significant figures. So here we're doing volume, which is multiplication of length times width times height. So it's multiplication. We've got 4 sig figs there, 3 there, and 4 there. So how many sig figs are we going to do for our answer? We're going to do 3 sig figs because that's the smallest one we've got. So answer 2, 3 sig figs. For the next one, adding and subtracting. So we've got 2 samples of copper chloride. We're putting them both in the same container. What's the total mass? So I'm adding these two numbers. So we don't do adding and subtracting in terms of significant figures. We do it in terms of decimal places. So here I've got 2 decimal places. Here I've got 1 decimal place. We give our answer to the one with the smallest number of decimal places, which is 1. So give answer to 1 decimal place. Alright, so some revision of stuff from phys sci. So we're looking really just at the molar mass here. If we're giving the molar mass of just one element, we call that the relative atomic mass, which is AR. The R here stands for relative. Because it's relative, we don't need to give units, okay? So the relative atomic mass of carbon-12 is exactly 12 atomic mass units, so I don't need to give units. Everything else is comparative to the mass of carbon-12. That's how originally the masses of things were decided historically. Okay, so the R basically means no units. Okay, here we go. An example. Please have a go at this one on your own. Pause the video, resume the video to see if you got the right answer. So, the relative atomic mass of magnesium is the 3 isotopic masses times by their percentage abundances. So the isotopic masses, so for magnesium 24, you'd think it'd be 24, it's actually slightly less. The reasons why are super complicated and not part of the course. So for the first one, we've got 23.985 times by its percent abundance as a decimal, so 0.7890, plus the next one, plus the next one. and put that in your calculator and you'll get 24.31. I'm going to 4 significant figures because the percentage abundances are given to 4 significant figures, and I'm not putting units because it is relative. Alright, if we're not dealing with just one element, if we're dealing with like a molecule or an ionic substance, then we use the relative molecular mass and the relative formula mass. Relative molecular mass is for covalent molecular substances because they have molecules. Relative formula mass is for ionic substances and covalent network because they don't have molecules, so we can't call it the relative molecular mass. Both of them just use the symbol MR. The R again stands for relative, so no units required. Now I reckon you guys can do this one without me as well. So the relative molecular or formula mass for these substances. So pause now, have a go, resume, check your answers. So for the first one, it's going to be the relative formula mass because there's no metals in there, so it's covalent molecular, but they have the same symbol anyway. So MR of COCl2 equals molar mass of carbon plus the molar mass of oxygen plus the molar mass of chlorine, where there are 2 chlorines. And I'll just pop that in the calculator. And I get 98.91. Now, because I've got this relative part here, I don't need to give units. If I had have said the molar mass of COCl2, of course the units would be in grams per mole. Okay. Now, the formula mass, relative formula mass of barium iodide, which is a formula mass because it's ionic. So MrBai2. So I need to go to my formula sheet because I don't know those ones off the top of my head. So barium is 137.3 plus 2 lots of iodine, which is, where is I in the alphabet? Here, 126.9. And if I put that into my calculator, I get 391.1, nothing, unitless. Okay, that's lovely. Down to the mole concept. Just checking I'm still recording. Yes, I am. Wonderful, fantastic. All right, what are we looking at here? Right, a mole. We know what a mole is again. This is just 5th Sci revision, so I don't want to go into great detail. If you feel like you can't remember it, then you can just read through this page. Okay. Right, so we know what a mole is, don't we? We know what Avogadro's number is. Okay, let's do this example. Again, please pause, try the example yourself, and then resume to check your answer. Okay, the number of SO3 molecules in, don't know if you can hear Cotton barking. She's unhappy with something on the street. Okay. Oh, she's so cute. Sorry. Cotton. Oh, darling. Okay, sorry, I should have paused for you there. All right, determine the number of SO3 molecules. So we've got the mass, and we can calculate the molar mass. So therefore, we can find the number of moles. So for part A, number of moles equals the mass divided by the molar mass. So 40.03 divided by what is, oopsie doopsie, sulfur, 32.06. So 32.06 and 3 oxygens. Right, I'm going to try and calculate that quickly so you're not waiting for me on the calculator for too long. Good job, me. I got 0.5. And I want to give that to 4 significant figures, like the question. Moles. Okay. Next, that is the number of moles. I need to know how many molecules there are. So, how many molecules are there in a mole? There's Avogadro's number amount worth. So, the formula is N, big N, which is the number of molecules or whatever, equals the number of moles times Na, which is Avogadro's number. So 0.5 times Avogadro's number, which is what? 6.02 times 10 to the 23. So I get 3.01 times 10 to the 23 molecules. Okay, B, how many sulfur atoms? 1 sulfur atom per molecule. So therefore, the number of sulfur atoms is 3.01 times 10 to the 23 atoms. Part C, how many oxygen atoms? Well, there's 3 oxygen atoms per molecule. So the number of oxygen atoms is 3.01 times 10 to the 23 times 3. 9.03 times 10 to the 23 atoms. Lovely. Well, I've just got a message from Ben here saying, what's happening with chemistry? Recording ATM. There we go. Lovely. Next. Molar mass. Oh my God, this is, seriously, we know this. Do I really have to do these? Right. Pause it, have a go, and then unpause and check your answer. I'm going to also pause the video and just write in the answer because I don't think you need me to explain this. Okay, there are my answers. So if you need to pause to copy that down, you have to do that because I'm going to keep scrolling. Okay, more moles. Amount of substance. All right, same thing again. Pause, try it for this whole page, I reckon, and then replay or whatever. You know what I'm talking about? Yeah, okay, good. All right. How many moles of ethane are present? So, number of moles. So, mass divided by the molar mass. 50.0 divided by the molar mass, which is going to be 2 lots of 12 plus 6 lots of 1.008. .663 sig figs, just like the question. Mole. How many molecules of ethane are present? B, number of molecules is the number of moles times Avogadro's number. 1.66 times 6.02 by 10 to the 23. .00 to 3 sig figs, surprisingly, times 10 to the power of 24 molecules. Okay, what mass of silver nitrate contains the same amount of substance, so same amount would be same number of moles, as 62.44 sodium fluoride. So let's find the number of moles of sodium fluoride and therefore the mass of silver nitrate. So the number of moles of NaF, sodium fluoride, is the mass divided by the molar mass, 62.44 divided by the molar mass of sodium fluoride. What is silver? Silver, 107.9. Oops, I don't want silver, I want sodium. What are you doing? 22.99. And fluorine, is with an F, 19. And the answer to that $1.487 sig figs, just like the question. Right, so now we want to know what the mass of that amount of silver nitrate would be. So the number of moles of silver nitrate, we're saying we want to be that. So the mass is the number of moles times the molar mass, 1.487 times by the molar mass of silver nitrate. What did I say silver was? 107.9 or something. Yes. 107.9 plus nitrogen's 14.01 plus 16, 3 oxygens. Okay, let me just calculate that. .7 grams is our answer to have the same amount of substance. Fantastic. Oh golly, this just keeps getting more and more fun. Oh, the sausage example is not too bad. All right, again, you might like to have a crack at this page. And then resume the video. Percent nitrogen in ammonium nitrate. I'm just going to fold my laptop back. Right. So communication is important. We write this as percent nitrogen in NH4NO3 equals. Okay. So cotton, we do the molar mass of the nitrogen, and there's 2 of them in there, divided by the molar mass of the whole substance, times 100 to make it a percentage. We love percentages. All right, so 2 nitrogens. So that's going to be 2 lots of 14.01 divided by the molar mass of the whole thing, which will be, I'm getting messier and messier, aren't I? 2 nitrogens plus 4 hydrogens plus 3 oxygens. .35. Oh, times 100. Silly me. 35%. Oh, fantastic. We like that. 35%. All right. Sausage question. How do I do this? Right, I think I remember that this was like like very slightly complicated, so I'm going to pause and do the question and then replay to make sure I don't stuff it up live. Okay, I couldn't tell if I was recording again or not. Okay, sausages. Good. All right, so we have a sausage roll. It's got salt in it, which of course is sodium chloride. A chemist precipitated out all the chloride as silver chloride and got 0.636 grams of that precipitate. So we've got salt, sodium chloride, and we are adding into this silver ions effectively. So that we can precipitate out silver chloride, and that leaves us with sodium ions. So the sodium chloride is the original salt, and the silver chloride is the precipitate that we get, which was 0.636 grams. So based on that information, I need to find out the mass of salt that was in there originally. So I'm going to need to have this equation. What? Oh my God. I'm going to need to have this equation be more correct because it's wrong at the moment. No, it's not. It's right, isn't it? Oh. I've done all my answers wrong because I thought silver was 3+, but that's aluminium, so they're both 1+, so that's actually balanced, isn't it? Okie doke. That makes the question even easier. 1-to-1 ratio. All right. Number of moles of silver chloride that was precipitated out is the mass divided by the molar mass. So 0.636 divided by the molar mass. So silver is 107.9 and chlorine is 35. Oh my God, yeah, 35.45. I'm going to need to recalculate that since all my answers are wrong now, which is really frustrating. 107.9 plus 35.45 gives me 0.00444. 3 sig figs like the question. All right, so therefore, the number of moles of sodium chloride, the salt originally in the thingy, is the same due to the 1-to-1 ratio. Okay, and the mass of sodium chloride is the number of moles times the molar mass, so 0.00444 times the molar mass, which is what? 22.99 for sodium, 35.45 for chloride. Okay, so we get 0.259 grams. So that's the mass of salt in the sausage roll. What is the percentage by mass? Well, we've got 0.259 of salt divided by the mass of the sausage roll, which is 8.45 grams. And to make it a percentage, I need to times by 100. And I get 3.07% of salt by mass in the sausage roll. Fantastic. I think I'm going to leave it there today because I've had enough. Yeah, so hopefully you remember that okay. We'll do some more either tomorrow or Friday. Fantastic. Thank you and goodbye.